This video will discuss the basics of using the script command line in VisualFoundation. Let's get started. The script feature in VisualFoundation is a powerful tool that uses a command line interface to create model objects, generate service cases, apply loads, extract results, generate reports, and more. All of the commands that are available for VisualFoundation are listed in the commands page of the help file. This help file also provides a written overview of the command line basics. The script tool is accessed by clicking the script tab at the bottom of the Find tool. Note that inputs and outputs in the command line are always in the current unit style. For this example, let's set the units to kips and feet. From the command line, we can add a rectangular slab to the model by using the Add Rectangle Slab command and entering the X and Y coordinates for the center of the slab and specifying the width and height of the slab. Note, to look up a command, we can enter its name inside quotes into the help command. This launches the help file and takes us to that particular command so that we can see the various inputs that it can receive, a description of what the command does, an example of how it is used, and an explanation of the example. In the help file, we see that there are commands to add rectangular, circular, and polygon slabs, in addition to an add slab command that generates a generic slab based on a list of X and Y coordinates or based on an array of locations. Next, let's define some variables to store the width and height of the generic slab that we are going to create. Variables circumvent the need to input the same number over and over again. Note, when storing a value in a variable, the line must end with a semicolon. Next, we will define some variables to store the locations that we will use to define the generic slab. For convenience, the up and down arrow keys on the keyboard are used to auto-populate the command line with previously entered values. Now we can use the Add Slab command and input the various locations to generate the generic slab. Next, let's move the center of the rectangular slab so that the two slabs do not overlap. Note, when using the name of a model item in the command line, F001 in this example, it must be enclosed in quotes. With the slabs defined, let's add some piers to the model. We can add a pier by specifying its X and Y coordinate, or we can add a pier using a location. Locations are particularly useful when we want to define items in the model so that they coincide perfectly with one another. For this case, we don't want the pier right on the corner of the slab, so let's change the location of the pier. Note, we can always switch back and forth between using the command line and driving the program in the traditional manner with the keyboard and mouse. Next, we can set the pier's shape type to circle and define the radius of the piers using the command line. Note, a semicolon can always be used at the end of a command to suppress the return value. The Set Pier Materials command is used to specify the material for a given pier. We can either enter in the name of the concrete exactly as it appears in the material database, or we can use the Pick Concrete command to launch the material database dialog box, allowing us to select a material from the list. The Pick Material and Pick Database section commands can be used in a similar manner to launch the general material database and the shape database respectively. These commands could be helpful for specifying the material properties and the shape of a steel pile, for example. Next, let's add a wall to our model. Since it is hard to remember all of the input options for the Add Wall command, let's look it up in the help file. We can copy the command with the inputs that we want, paste it into the command line, and enter the desired values for the inputs. In addition to the various commands that are built into VisualFoundation, any valid C# code can be used in the command line. For example, we might want to add a semicircular slab to the project, which might prove challenging to draw by hand. To create this slab, we can define a function for X in terms of Y for a circle that has a radius of 6 feet and is offset from the origin by a -4 feet in the X direction. Next, we can create variables to store a list of the X coordinates and a list of the Y coordinates. Then we can use a for loop that starts at y equals -6 feet and ends at y equals 6 feet, incremented by 1/4 of a foot, to populate the list of x coordinates using our function, and a list of y coordinates. Finally, we can add a slab to the project that is defined by the lists of the x and y coordinates that we created. Having created the model objects for the combined footing, let's work on applying some loads to the model. Walls or grade beams can be loaded using the load line command. Let's apply a vertical force as a resultant in the z direction for the selected wall in the current service case. We can then apply loads to the selected piers in the current service case using the command line. Also, we can specify the service case and piers in the command line that we want to load rather than selecting them in the model and loading them only in the current service case. In addition to creating model objects, the script command line can be used to extract analysis results including slab displacements, shears, moments, and bearing pressures. For example, we can use the bearing command with the Boolean value set to true to return the maximum bearing pressure across all the load cases in the model. We can use the same command to return the maximum or minimum bearing pressure for a specified result case. Furthermore, we can specify the location in this command from where we want to extract the result in the model for the defined load case. At any point, we can enter clear into the command line and press enter to clear the script and reset any of the stored variables. In this video, we've used some built-in commands and basic programming to create and load a combined footing and extract results. More advanced programming can be performed in external scripts that are read into the program as discussed in the External Scripts training video. Thanks for watching and have a great day.